Okay, here I have a function f that's a function of two variables, x and y. It looks like this. So I want to find this expression, f sub x, which is the partial derivative of f with respect to x, the partial derivative of f with respect to y, and then I want to evaluate those two things at these points on the graph. So when I find this expression right here, f sub x, it's the partial of f with respect to x. So when I differentiate this expression, I treat x as the variable and every other variable as a constant. So I look at this and I see it's the quotient rule, so I have to apply the quotient rule, and then I differentiate with respect to x. So by the quotient rule, I'll have the denominator, 5x minus 3y squared. So that's the denominator times the derivative of the numerator. So when I differentiate x squared with respect to x, I get 2x. I treat y as a constant, so this 3y is just a constant itself, so that derivative is 0. So I'm done with that. Minus, so I did the denominator times the derivative of the numerator. Now the numerator, x squared plus 3y, times the derivative with respect to x of the denominator. So I differentiate 5x, I get 5. Minus, I differentiate 3y squared, where y is a constant, I get 0. So that just turns out to be 5. And that's all over the denominator squared. 5x minus 3y squared squared. So if you can get this right here, then you understand partial derivatives using the quotient rule. The rest is algebra trying to simplify this. So let's see what we can do. Here I have 2x times 5x, that's 10x squared. Here I have minus 5 times x squared minus 5 times x squared. So this is going to be 5x squared. And then I have 2x times negative 3y squared, so minus 6xy squared. And then I've taken care of that, so I have this. 5 times 3y is 15y, and that's negative. So minus 15y, all divided by 5x minus 3y squared squared. So from here to here is just algebra. If you make a mistake in what you get right here, you've just made a mistake in algebra. This is the calculus part of the problem. So it's the quotient rule, and I find the partial of f with respect to x for this expression. I use the quotient rule, I differentiate with respect to x, and I treat all the other variables besides x as constants. So I get this. So let's go down now that we have this and evaluate it at this point right here. So I'm going to take this expression, I'm going to substitute in 0 for x and 2 for y. So what do I get? 5 times 0 squared minus 6 times 0 times 2 squared minus 15 times 2, all divided by 5 times 0 minus 3 times 2 squared squared. So this comes out to be 0 minus 15 times 2, so minus 30. And then this is 0 minus this, so that's 4 times 3 is 12, negative 12, and then squared is 144. So let's see, that's negative 15 over 72. I'll divide those by 3 and get negative 5 over 24. Okay, so that's this expression right here evaluated at the point 0, 2. So there's the partial of f with respect to x. There it is evaluated at a specific point. So now let's go to the second one. Let's differentiate this same expression, but with respect to y. So now y is the variable. All the values of x are just constant. That's the way I look at it. So I'm going to use my quotient rule. So it's the denominator, 5x minus 3y squared, times the derivative of the numerator. Well, the derivative of x squared, if x is a constant, is 0 if I'm differentiating with respect to y. So that's 0 plus I differentiate that with respect to y and I get 3. minus, okay, so that was the denominator times the derivative of the numerator. Now the numerator, x squared plus 3y times the derivative of the denominator with respect to y. So that's going to be 0 minus 3y squared. So I'm going to get, when I differentiate that, minus 6y. And all of that is over 5x minus 3y squared squared. So I can go ahead and simplify that if I want. I'm not going to do it here, that's just algebra, but this is the quotient rule applied to this expression when I'm finding the partial derivative of f with respect to y. So now let's evaluate this right here. So when x is 0 and y is 1, this expression becomes 5 times 0 minus 3 times 1 squared times 3 minus 0 squared plus 3 times 1 minus 6 times 1, all divided by 5 times 0 here minus 3 times 1 squared, all squared. So what do I have? I have 0 minus 3 times 1 squared. 3 times 1 is 3 times 3, so I have negative 9. Okay, and then here I have 0 plus 3 times negative 6. So this is negative 18, and I want the opposite of that, so plus 18. And down here I have 0, I have 3 times 1 squared, which is 3. So I have negative 3 squared, positive 9. And so what do I end up with here? Negative 9 plus 18 is 9 divided by 9, 1. Okay, so that's the value of this partial derivative when x is 0 and y is 1. So really good problem to see if you understand partial derivatives and using them with the quotient rule. That's about as hard as it gets right here. Notice on the second problem, because I wanted to evaluate this down here, I didn't have to simplify this. I could just substitute in 0 and 1. That saves me, in this case right here, from making a mistake in algebra. So from this step to whatever I get to simplify it, that's algebra, but this is the calculus right here. So really good problem to practice. Do it until you can get it right.